Alright, so I wanted to do a more in-depth demonstration of the control software here so that people can get a better understanding of what's in here. So first, before we actually connect to the robot and control it, let's talk about the control software itself. So what you're looking at is a completely web-based control software written in React. Currently it's running on my Mac, but you can basically run it anywhere you want. You could run it on a Raspberry Pi, so on and so forth. It gives you the ability to connect to different robots. There is some code that basically runs on the robot itself, which I can go ahead and start up over here. If I start that software up over there, then you can see there's log output from the controller on the left and log output saying all the motors are ready on the right. So this code on the right is running on the Raspberry Pi. When that booted up, you can see I now have a robot to select from over here. But we're not going to do that quite yet. First, we're going to talk about the simulator itself. So the first thing you see is I can go ahead and hit this go button and go to a specific location, right? And I picked the negative z-axis here. So if I go, you can see in the simulator it went to that position. In addition, I can use my arrow keys to move this ball around, like so. I can go up and down, I can go left and right, and I can also use the ASDW commands to move the Euler angles around of the ball there, right? So that's one example of controlling the robot via this interface here. In addition, it has the readout of all the angles that the joints are currently set to and the current location of the end effector. Now you might have noticed as I was moving the joints around, or the robot around, that on the left side of the screen the inputs are also changing. I could go ahead and actually grab that and even swing, J1 around, swing J2 up and down. That works as well. I can control everything on the left here. I can control the X direction via these inputs, the Y direction, and the Z direction via the inputs as well as the different rotations R1, R2, and R3, right? So I can do all sorts of things just with the simulator, and the reasoning for that is so that I can test things before I want to run them on the actual robot. Now, what are these colored things down here? Well, let's talk about those. If I actually shut off the main grid and I hide the robot, we can actually see some color-coded lines here. And basically what these lines represent are the distances between the joints. So you can see the red, if I increase the size of the red, then that will increase the length of that joint. If I increase the size of green, blue, the yellow one and the purple one, right? And let's go ahead and turn the robot back on, right? You can see that we now have this really ugly elongated robot, right? So I'm going to go ahead and refresh the screen so we get back to our initial state. Currently I have this loaded up with the AR4's parameters, and that's why if you look at these values over here, they're actually in centimeters. So they actually match the distances that are in the AR4, but slightly different kinematics than the AR software itself. That's why the values are changed a little bit different. At the bottom you can see we have some different toggles, so I can actually hide the main grid, I can actually hide the robot, and then I can turn on the joint grids and even hide the negative values, and now I'm actually looking at the kinematics of that robot. So if I was curious to see the kinematics diagram, there's the kinematics diagram. If I want to shut off if I want to show the robot again and turn on the main grid and hide the joint grids, I can also show the link color, so I can actually see, this is green. If I extend green, you can see that's matched up to that. So I'm going to go ahead and refresh this again to get to a nice clean state. Now that's a little bit about the software itself, but one thing I didn't talk about yet is another addition that I added, which is running an actual simulation. So if I go ahead and click this arrow icon here, you can see I have a run simulation button. Now I'm going to toggle off run on robot because I want this to just run on the simulation. Now it wouldn't anyways because I'm not connected to a robot, but you want to make sure that that's toggled off. I'm going to go ahead and hit run simulation, and what it's going to do is it's actually going to play every single movement here. There's a speed, a hold time, and an XYZ location, as well as a drop down that you can select what direction you want the end effector to face. In the future I'll make it so you can do different weird angles, but right now it's just X, negative X, Y, negative Y, Z, negative Z. So you can see it ran that simulation. So if I go ahead and close that, this is all cool and all, but let's actually connect to a real robot. So I'm going to go ahead and connect to the real robot here, and as you can see on the right hand side we have a readout of all the different joints. Let's go ahead and take a look at J0 here, right? So the first joint says it's ready. It's not homing, it's not home, it hasn't ever been homed, but it is enabled. It's not moving. This is the current step position, and this is current encoder position. There are no errors on this joint. If I go ahead and I click on the home button here, you'll see that the robot in the real world actually starts to home. So it's running the homing sequence, and when it's done, it's just going to basically stop at the home position. All right, now that we're home, I'm going to go ahead and hit the center button. We're going to go ahead and center the robot. It should be nice and perfectly upright in a second here. So with the robot in the center position, I can go ahead and click Run on Robot here. And I can actually tell the robot to go to a specific position. So you can see the robot is actually going to go to the same position that you see in the simulator here. If I were to move that, let's say, forward on the x-axis, you can see it move forward on the x-axis. If I want to move it way back to, let's say, 30 centimeters from the base, it did that as well. Maybe I want to move, I don't know, 20 to the side. Boom, I moved 20 to the side. And now I want to recenter it. We can send it back to the original position here. As you can see, when I do that, the parameters on the right are updating. So I know it's been homed, I know it's enabled, I know it's not moving. But if I tell it to go to this position, you'll see that this is it's now saying it's moving, and you can see the encoder position updating and the step position updating there as well. So I'm going to go ahead and center that again. So another thing we're going to go ahead and do is we're going to go ahead and basically, let's actually send the robot back to that position, and then we're going to go ahead and move one of the joints individually. So I'm going to go ahead and grab this joint here and move it a little bit. You can see as I slide that, it's moving the motor for J1 on the robot itself using this slider and updating the simulation at the same time. Now let's say something weird's going on and I want to debug that weird thing that's going on. Well, I can actually go ahead and go to another endpoint, motor, which is /motor in the URL, which you can't see right now, but I'm going to add a navigation for this. And I can actually debug a specific motor. So I'm going to select robot 1. I'm going to select motor, I don't know, J0 here, which is the first joint. You can see a readout of that here, and I could go ahead and I could just home that specific joint, or I can actually tell that joint to move to a specific position if I wanted to here. So that's just another interface where I can control and debug the motors individually. If I go back to the main page here and I reconnect to my robot, we'll finish off by actually showing that the Run on Robot is on. I'm going to go ahead and open up this and click on Run Simulation. Now that I click on Run Simulation and Run on Robot is toggled on, the robot is actually going to go to all the different steps and follow exactly what the simulator is doing here. So you can see the robot's running all of those different motions. I have no holds, so that's why it's actually not doing any sort of pause in between. It's just going from one to the next execution. But I can control the speed and all that type of stuff from this interface as well. Another thing to note is I could actually go ahead and tell it to go to a specific position. Let's say I want it to go down here. But I can actually freeze the robot. So that button just froze the robot in place. Right? And that's important because sometimes you might want to stop it, but you don't want all the motors to lose power, which is what this stop button would do here. But because I froze it, it didn't lose its position. So I could tell it to recenter, and it's going to go back to its center position. So that's a little update on the project and basically showing off the user interface and some of the things that it can do. I hope you guys enjoyed the video, and I look forward to keeping you up to date.